Hey guys, let's have some fun with a word problem. The Apollo 11. Before Apollo 11 descended to the surface of the moon, it made one orbit at a distance of 3 miles above the surface of the moon. At one point in its orbit, the onboard guidance system measured the angles of depression to the near and far sides of a huge crater. The angles measured 25 degrees to the near side of the crater and 18 degrees to the far side of the crater. Find the distance across the crater. Ah! It's a word problem. Where do we begin? Well, we actually just did it. We read the problem. Now, my advice would be always, when in doubt, draw it out. And if you can see it right now, there's actually two triangles at work. And we're going to be using them to solve this problem. So, when in doubt, draw it out. We have two triangles, okay? And notice that none of this is drawn to scale. So, I drew the first one out, and I made it, kind of nice, I hope. So you could clearly see the horizon, right? Then the elevation drop, 18 degrees, that's our angle of depression. So then we just had to find the angle in question that would be made left over. So 90 minus 18 gives us 72, and that's where I came up with the 72 degrees. Then I labeled my triangle appropriately: hypotenuse, opposite, and adjacent. And then again, I also made a little subscript label of the distance of the far region. Okay? So in the far side of the crater, right? So what we have is this distance here that we're going to be talking about. And this distance here is the distance for the far region of the crater. So we then did the near side of the crater, and the angle of depression is 25 degrees. So 90 minus 25 gives us 65 degrees. I labeled the triangle appropriately: hypotenuse, opposite, and adjacent. I then labeled the opposite side the near side. Why? Because this horizontal distance is what we're counting on as being the distance to the near side of the crater. So, before we go on, what we're looking at, remember, is this distance here to here. And it's a little hard, it's a little tricky for some reason to get it right. Okay, so we won't do that. We'll just do this as best as we can and see if it works. Nope, it's not going to work. But you can clearly see that this is the distance that we're looking for. Okay? And that means that we have two different ones to look for. So I redrew the crater out. So the difference between the near and far sides of the crater will give us the length of the crater. So I made a little diagram here to help visualize what's going on, and this is the crater. So we know that the distance of the crater will be the difference of the far minus the near region. So what we have to do is find this distance for the far, which is the total distance, and we have to find the initial distance. Okay? So what we did was we found the two different distances, and in both we used the tangent because we're both dealing with the opposite and adjacent sides of our triangle. So in our first one, we have the far side of the triangle. We know that we're going to be solving for d sub far, right? The distance for the far region. So we set up tangent of the angle in question is the opposite over the adjacent. Okay? So we set it up, and then we solved. Plugged it into the calculator, making sure it was in degree mode. I got 9.23 miles. Then we found the distance for the near side of the crater. Drew it out again, just basically recopied it from before, and notice that I'm also looking at the opposite and adjacent. We don't know anything about the hypotenuse, so again, we're going to use the tangent. So the tangent of 63 degrees, the angle in question, is its opposite, which is the distance for the near, over its adjacent. So we then solved and came up with an approximation of 6.43. I then wrote out the answer for find the distance of the crater, and we know that that's a difference between the near and far side, right? So the bigger minus the smaller will give us the between, the stuff that's stuck in the middle. So what did I do? I wrote an exact solution. This is what we would call an exact solution. Something interesting that we could factor out, but it's not the tangent, right? We could factor out a 3, but that's it. Okay? What I did then was substitute the values in, and then did the actual subtraction. Found out that it was about 2.8 miles and recorded it as such. The distance of the crater is approximately 2.8 miles wide. And that would conclude the problem. Now, to recap very quickly, how you decide to look at a word problem. Well, there's a lot of stuff that's extraneous, right? There's a lot of stuff that we don't really need to know. If you really were picking out the right things, we know we have an orbit at a distance of 3 miles. Well, what does that mean? Well, if this is the ground, right? Then at some height, I have 3 miles. I know I'm 3 miles above that ground. At one point in its orbit, so now we're stopped. We've actually fixed ourselves in time and space, and we've said that's where we are. The onboard guidance system measures angles of depression to the nearest far sides of the crater, okay? The near and far. The angles are measured at 25 and 18, respectively. So that means we're going to have 2 different triangles. One, right, that when we look out to the horizon, we know that we're going to be dropping 18 degrees. Okay? So that would be our 18-degree drop. We also know, and you can see very quickly, that we do in fact have a right angle. So there's our first triangle. The next one we have is the swinging down, or the angle of depression of 25 degrees. So then we make another triangle down here, and you can clearly see that now we have the 2 triangles. So when you are looking at how to solve a word problem, your whole aspect is to avoid all of the information that is extraneous. You are there to pick out what is most important and then draw it out. The better you get at this, the better everything will be in the mathematics language. So this was just a little recap of how to do a particular type of problem, and I figured we'd use Apollo 11. Hopefully this helps. Help you understand the angles of depression, primarily, because we didn't really talk about angles of elevation. But hopefully all this makes sense, and you will give me feedback. All right, thanks. Have a great day. Bye.